This DeBacco University video, I'm going to go over the SI system here, where we're looking at units and standard units for certain measurements that we'll be taking and documenting in lab. All right, you're probably familiar with some of these units: time, length, mass. Well, seconds, meters, kilograms, electrical current is amperes. Those are going to be our standard units that we're going to be utilizing. So as anything, units are very important. Just like currency of money is important, so are units for science. And I stress this because a lot of times you may not have the unit that you need. So you'll have a unit and you have to do a conversion factor to make that unit translate into the unit that can be applied to mathematical equations. So think of like exchanging currency from one form to another. Now the fundamental SI units here, the system, again, length, mass, time, temperature, electrical current, luminosity, amount of a substance. These are the typical units, and this the unit symbol that you most likely have seen. So meters, kilograms, seconds, Kelvin, ampere, candle, and then mole there. So we may be familiar with some of these. We may know some of these, like for example, centimeter, we may have to convert to meters or vice versa. So the prefixes, common in chemistry, you can see them kind of listed out here, and this kind of graph kind of shows a nice little comparison. Well, here we're looking at kind of the 1 being the standard, and then if we go smaller or larger than that, here we're basically increasing or decreasing by a factor of 10. So kilogram, again, representing 1,000, for example. That's one that's very commonly used. And the other example I just gave was centimeter. Here we're looking at basically 100 base. So these are something you might be familiar with. Some you're going to work with more than others. So when we're making that conversion, we want to think of like the metric ladder. Each step is, again, a 10-fold difference. So the decimal can simply be moved one space for each step. That's going to be to the left or to the right, depending on whether we're going to one unit versus another. So for example, going down here, we're increasing the number because it's getting larger, because that unit's getting smaller. A milligram or a milliliter is going to be much smaller than a kiloliter, kilogram, for example. So how do we go about those conversions? Again, here we can try to memorize this, but really, if we just kind of have an understanding of the basic conversions, it becomes quite easy, especially when you're going from millimeters to centimeters. Well, you're simply dividing by 10. There's centimeters is a larger measurement, millimeters are smaller, so you can also apply just general common knowledge, hopefully, as well. You can see some numbers can get quite large, millimeters to meters. Again, you're dividing by 1,000 there. And again, it's just kilometers to meters to centimeters to millimeters. You're going through that kind of 10-fold step each and every time. So how does this kind of look? Let's go through an example here. Conversions in the metric system are merely a matter of moving the decimal point. The base unit means you have a quantity, which is grams, meters, liters, without a prefix, for example. So if we look at our conversion here, example 1, convert 18 liters to milliliters. So we've got our liters and we want to go to milliliters. So how are we going to go about that? Well, here's our 18 liters. That's our base unit. And we're going to move it 1, 2, essentially 3 decimal places over. So that's allowing us to make a conversion there. We're converting liters to milliliters. It's going to be a much larger. So we're going to move that 3 spaces to the right, making it a much larger number because milliliters are a very small unit of measure. Liters are larger. So 18 liters would be converted to 18,000 milliliters. Simply move that decimal 3 places. Here we're looking at milligrams to grams. Again, so now we're starting way down here, 450 milligrams. Well, if we convert that to grams, we're going to go 1, 2, again, 3 decimal places in this example, and that would be simply 0.450 grams. We have to move that decimal place 3 spaces, and grams are larger. I could see, again, looking at 20 kilograms to milligrams, you can see how these numbers can get quite large. This is where we may be using scientific notation, which is described in another video. And then at 20 grams, how do we go about that? Well, the same thing generally applies. You're just moving it 6 decimal places, which is how you're getting to that 20 million milligrams again here. So numbers can get quite large. The time for SI unit is based on seconds, but other common units include, of course, minutes, hours, days, weeks, months, even years. And those can be easily converted. And this is a great way to kind of go about that, to understand how to convert things on a unit you might be more familiar with. Electrical current you may not be as familiar with. The primary unit for measuring is amperes, or represented by the capital letter A, which represents the flow of an electrical charge. You might have heard of volts or maybe ohms for resistance. Well, amperes is the measure of that electrical current. Now, the amount of a substance is a mole. You're going to hear definitely more about this within chemistry. Mole is a unit of measurement that represents a specific number of particles, which is exactly 6.02 times 10 to the 23rd. So you're going to take that decimal and move it 23 times. It's an extremely large number. It's known as Avogadro's number, and consider it like a chemist's dozen. We say a dozen, we know it's 12. When we say a mole, we know it's this 6.02 times 10 to the 23rd. And lastly here, luminosity. It's a measure of the wavelength of light. It's a weighted power emitted by a light source, and it kind of gives you an idea of the intensity there. It's a standardized model of the sensitivity to the human eye. Greater luminosity means essentially just think of it as being brighter there. So all these kind of rules apply. All these areas have standard units of measure that we can convert to others. So you might want to start with one you're more familiar with and progress to one of these because the same basic process applies.